Welcome everyone, this is super exciting. We're honored to have those two people, those two giants in the field sitting next to me. So on the one hand we have Gary Marcus. He's a cognitive scientist and author, Professor Emeritus of Psychology and Neuroscience at NYU, entrepreneur and a leading public voice on AI and AI policy. And then we have Karl Friston, a professor at UCL, chief scientist at Versus, and if you don't know who he is, you're in the wrong room, I fear. So let's get started. So we're intended to talk about the future of AI, but let's get started by reflect a bit on the current state of AI. And when people outside of this room think about AI, they typically think about generative AI or LLMs. And rumor has it, Gary, that you're not that fond of LLMs. So can you maybe quickly give a summary of what your critiques are on the current state of LLMs and where they're going?
Sure, but first I'll mention that yesterday Noah Smith, who goes by Noah Opinion on Twitter, had a tweet about how AI haters were medieval peasants. And I couldn't tell whether that was supposed to refer to me, because a lot of people describe me as an AI hater, but you got the scope right. I don't hate AI. I actually love AI. I wouldn't spend all of my time reading and writing and I built a company, which I sold to Uber, and so forth. I wouldn't spend all this time on AI if I hated it. But I do hate LLMs. I'll be honest about that. They have their uses. Another straw man of me yesterday was to imply that people of my kind, anyway, think that LLMs are useless. And I've never said that. I think that they do have some uses. I just think that the negatives are probably outweighing the positives, and there's multiple kinds of negatives. So the positives are, for example, they help sophisticated coders do some of the drudge work of coding. They may help poor coders make really insecure code. We could talk about that. But they certainly help coders. They help with brainstorming. They help with translation. They help non-native speakers write. So they do have some value. But I think that there's a wrong way to approach AI. I think you need world models at the core of how you build AI, or else you hallucinate. And I've been warning about that since 2001, before there were LLMs. In my book, The Algebraic Mind, I said if you use these kinds of neural networks, and the LLMs are descendants of the kinds that I was talking about then, you're going to have problems of overgeneralization, and you're not going to get your facts right. And that's been a problem for a quarter century. So there are reliability problems. There's also a weird kind of cultural problem, which is we have an intellectual monoculture right now where everybody is basically doing the same thing at really enormous scale. There's this old line about the definition of insanity is doing the same thing over and over again and expecting different results. Well, may I present to you the field of AI right now, where people keep building larger and larger LLMs, hoping that it'll magically solve the hallucination problem and what I call the boneheaded reasoning or boneheaded error problem. We still get that. Like, none of this has really changed. Maybe it's reduced a little, but clearly these are not fundamentally safe architectures. And then you have the kind of moral and political problem. So how do you make LLMs work? Well, first thing you do apparently is you steal all of the data from every artist and writer ever, and then you try to persuade the government that that's okay and the copyright laws don't apply to you. I don't think that's okay. And it's led to, I think, some very poor choices on the part of a lot of people running the AI companies. And clearly what they want to do is to take your job and make you watch slop and porn all day. And like, I mean, that's almost not even a joke. That's like, Altman 2 weeks ago was like, we have really hard choices because we have a shortage of chips. Of course, he needs a lot of chips because his technology is not very efficient. But putting that aside, he says, you know, we have a shortage of chips. And so we're gonna have to make hard decisions like solving cancer in the next year or two, or fixing education. The reality is that LLMs are not going to solve cancer in the next year or two. Even if they were like these super genius things that they pretend they are, you'd still need to do the clinical work, and it just tells you that Sam has no clue about clinical work if he thinks it's remotely possible to solve cancer in a year or two. So, I mean, it's all bullshit. Can I say that here? Aside from the fact that it's all bullshit, that was late September. Here we are in mid-October, and what is he actually doing with his chips? He's revealed that he's going to inside a mental health announcement, he reveals in the last paragraph that they're going to start asking for ID because they're going to have, quote, erotica, which I think rather dignifies the garbage that's going to come out. And he said that he's going to make a competitor to TikTok that's going to be all AI slop generated by Sora, unlicensed, all the time. So, like, there's the political side that also makes me hate not AI, but LLMs used in this way. Like, there are got to be better things. I had an op-ed, and then I'll surrender the microphone because I'm obviously going on for a long time. I had an op-ed yesterday in the New York Times, and the way I ended it is by saying maybe we need to focus on more special purpose models that don't make all of these mistakes, that do particular things in medicine, education, and so forth. I didn't say rather than making porn and slop, but I think it was implied. And so, like, I think we can do great things with AI, but maybe not in the way that LLMs are doing them.
Yeah, I think this gives us lots of food for thought for the next 30 minutes. Karl, on your end, a year ago, you said, and I quote, "Deep learning is rubbish." Do you still stand with that quote?
Yes, I do. Yeah, but let's just contextualize that. I had to say something entertaining and controversial, very much in the spirit that Marcus has been invited here Gary's been invited here to entertain us. So you should say the things because people love to hear that, but none of us dare actually say them. So it's great that you're actually.
Can I interrupt just briefly? What's really interesting to me is how much the world has changed in the last 3 months. I got so much, as long as I'm being foul-mouthed, so much shit in the last 7 years as, quote, AI hater, and people question my intellectual integrity. It's really kind of hard being me for the last 7 years. And then people noticed when GPT-5 was not what it was supposed to be. So one of the things I kept saying is that GPT-5 is going to be late, and it's not going to be AGI, it's not going to be magic. And it wasn't. And people really noticed. And I have been treated so much better in the last couple of months. Now people want to hear me diss LLM. So it's a fun moment.
Your time has come. Anyway, why did I say that LLMs or deep learning was rubbish? I think you could play that angle or sort of justify that perspective from a number of different angles. You mentioned efficiency. That would be certainly one angle. What I was specifically getting at in the conversation with Jan LeCun at that point was the failure of large language models to encode uncertainty, basically. In his language, not that came out in the conversation, but in his language, he would certainly be perfectly okay with formulating AI as a free energy minimizing process, but the free energy would have to be equipped with a zero temperature. And what that basically does is it nullifies the entropy. So you're basically talking about a tech that has no capacity to encode uncertainty. And what does that mean? Well, it means you can't encode what you don't know. So you have to look everywhere. You have to steal all the data because you've got no way of knowing how to be curious. So we're just seeing with Jantana's beautiful presentation the fundamental importance of being curious, resolving your uncertainty to get to that kind of sample efficiency, which precludes or obviates the need to then go and steal everybody's data in a really inefficient way. And I can't remember how the conversation developed, but certainly from the point of view of sustainability, I think that's a really important argument. But you could play that in many, many different ways. One thing which, having introduced Jan LeCun, I'd like, because you've had lots of lovely arguments with him, and I sometimes see him and you on the same side because you're both rebels without a cause in some respects. But there's one thing which I don't understand. It's the use of the word world models and generative models. Now, I've always understood generative models in the spirit of Geoffrey Hinton and the Helmholtz machine as a sort of probabilistic specification of the cause-effect structure of content. And yet Jan seems to say you shouldn't be using generative models. And I notice you carefully use the word world models. So I'd be interested to hear what do people mean by generative AI, and what is the implication for generative models in the context of generative AI?
Those were two really different questions. So before I get to either of those questions, I'll just say I think you're exactly right about uncertainty and these systems not representing in that. And that's a very serious problem. So all the hallucinations, for example, they fail to give you a confidence around it. I wrote a whole essay about my friend Harry Shearer, who's all of you know his voice because he does the voices for some of the characters in The Simpsons. Probably all of you have seen it. And he was the bass player in Spinal Tap. So he's a pretty well-known actor. And it's very easy to figure out where he was born. In fact, you can just go to Wikipedia, or you can go to IMDb or Rotten Tomatoes or anything like that. And somebody sent him a biography, which he gleefully sent to me, where it said that he was a British actor, comedian, etc. So the system hallucinated where he's from, even though it's trivially easy to find on the internet. A proper system, the very least it should do, is to weigh the evidence and say, I see thousands of things on the internet saying he was born in Los Angeles, and yet here I am compelled because I have a language model that sticks things in embedded spaces and loses track of them, to say that he's British. There must, you should have some probability assigned to that, some confidence interval. It's one of a zillion examples of these systems. That's why I say it's authoritative bullshit. It's the authoritative part is it presents everything with 100% confidence, even when it should not, with 100% certainty when it should not. Okay, so if I completely agree on your first point that is central. This audience fully understands that. I don't always use that terminology in a lay audience, but your point about uncertainty is 100% right. Second, LeCun, we're famous for having arguments, but the arguments all happened in 2019. In 2018, when I said that deep learning, I didn't say it was rubbish, but I said that it had problems, and he said that I was mostly wrong. And he never spelled it out. And then in 2019, I said LLMs didn't work, and he said I was fighting a rearguard battle. So what people don't remember, they all remember that we had a fight, but they don't remember what the positions were. And his position was that LLMs were hunky-dory and that this was great progress. This is, in fact, his position up until November of 2022, when he released a model called Galactica, which he thought was fantastic. And he bragged on it. And he said, look how great it is. And a bunch of us, including me, but not limited to me, showed that it had problems too. Like there was a journalist who showed that it would happily write essays like, what are the benefits of eating crushed glass? Or it would extol anti-Semitism and so forth. And so Facebook, not me, but really Jan, decided to remove it. And Jan's very bitter about that. And then what happened is it's true, and I mean, it's amply documented on Twitter. And then what happened is 2 weeks later, ChatGPT came out. It was actually a very similar model. And he was bitter, and I sort of understand, because that model became really popular, and his, which was technically really not that different. It didn't have the guardrails that it should have. He felt very bitter about it, and that's when he turned against LLMs. So ever since then, he sounds just like me, except that he won't cite anything by Marcus, and I often do. But that's the only difference between us now. So, I mean, it's another way of saying I won the argument, but nobody remembers what the argument was. They just remember that people were upset. But if you go back and look at the actual arguments, there's nothing that he said then that he still believes. And everything that I said then, he now does believe. So it's a little bit strange. Okay, so now world models. There are actually some genuine differences between his view and my view, although we've never really argued about it because we don't really talk anymore because he won't cite me, but anyway. So world model for me is partly a symbolic representation. I can conceive that there might be a way of doing it without things like databases and ontologies and so forth, but I've never seen anything remotely successful doing that. All the AI, this is probably too strong, most of the AI that I know actually does have explicit world models. I'll give you an example. The navigation system that got me here today. I kind of know Montreal a little. I didn't know exactly from the hotel or whatever. So I just followed the GPS system. Well, the GPS system has a world model, literally. It has a model of what the streets are, what the connections are, how long it takes to go. So I chose to walk. It told me 10 minutes, which was about accurate, except I walked faster. But, it was close enough. And so it does its computation by a simple classical AI algorithm of finding shortest path given a list of routes. Similarly, Wikipedia gives you a world model that tells you a bunch of things about Harry Shearer, like what are the movies that he's been in. The thing also hallucinated that he was in Jaws, and he had nothing to do with Jaws. Although there it turns out that there was one web page that got it wrong, and the system doesn't know, again, lacking certainty, it doesn't know that like one place reported this and it's not verified. It can't actually reason through those kinds of things. So there is the Wikipedia stuff. I mean, this is even in the boxes, right? The boxes in Wikipedia are the easy stuff that we actually do know how to deal with. The structured text, all of that gives you a world model. Where was he born? When was he born? Et cetera. You just look it up. Any credible AI should at least be able to use that stuff. So for me, a world model is that. And I think we have lots of world models. For example, my kids just watched the Harry Potter movies. I watched a little bit with them. And so you have a fictional world model where there are wizards and things happen with those wizards. And like you understand that that's not going to happen here. Nobody's going to ride in here on a broomstick. But it would be weird to watch a whole Harry Potter movie with nobody flying on a broomstick. So we have multiple world models, in fact, and they can be incomplete. Like I have a model of this room. I'd say there's 100, 200 people in here or something like that, but I can't tell you the exact number. I can get some sense of like, distribution, demographics, age, and stuff like that. I can't give you all the details, and that's fine. You don't need to have all the details. I know enough for present purposes. If I need to know more, I can zero in on this table and try to figure, okay, there's this many people there, and so you can make them detailed. So world models don't have to be infinitely detailed, but they need to be structured, and I don't even know how to say this word, interrogable. You need to be able to ask them questions and reliably get answers out of them. You should have a world model, and I should be like, who's this guy sitting next to me? And I should be able to, figure out something about it and remember something. Remember some of the places we've met before and some of the places we've spoken. It might not be perfect. We might have met enough times that I don't remember all of them, but I remember, sitting in your office, whatever it was, 6 months ago, and I remember we did an event in Davos 2 years ago, and so like I have a lot of detail there, not infinite detail. I don't remember every sentence that we said, but I use that centrally for almost everything that I do. Now, there's a different sense of world model, which I've seen DeepMind use and which I suspect that Jan might use, which is something like, and I think you alluded to, it is something like a function that predicts things. And that's also a kind of world model, but I think it's not what I'm looking for, not all of what I'm looking for. So there is a sense in which a world model is a function that predicts things, but I'm also looking for something that has the structure and the facts, and it should probably have probabilities attached to it, right? The classic symbolic AI version of it was basically not quantitative and not probabilistic, and I think a fair discovery of the last 30 years is you really want that probabilistic information. I mean, in fact, the thing that LLMs do well is they have some probabilistic distributional information, but they don't have the uncertainty represented at all. You actually want all of this. So, getting to the right AI is going to require doing some hard work around it. And I'll say one more thing, which is people might have seen, I think it's called CTS, blanking on the name. There's this new model just came out a day or two. It's a biological model predicting things about cells and so forth. CTS scale, I think is the last word. This is a system that actually has many different carefully engineered bits of knowledge that are structured. Like there's this imagination, you can just throw everything into a black box. But that's the most successful black box-ish model that I've seen, and it still like has specific representations for how it represents cells, and there's this incredibly intricate curriculum for how you train it, what pieces of knowledge, and so forth. The right answer to AI is really going to be different in different domains, is going to have a lot of structure, and some of that's probably going to be a world model.
If I understand you well, your notion of a world model is more or mainly about structuring the knowledge and being able to interrogate the structure. But what I'm missing from your interpretation is the concept of action. Like, how can you have a structure? How can you build a structure of this room if you're not able to walk through this room and experience walking through the room and meet the people in order to have like a concept of how many people are there? Like, don't you need the action fundamentally there to build the model?
So there's two pieces to that. The first I will call a friendly amendment to what I'm saying. The second I'm not sure I agree with. So world models also have, I didn't go into all this. World models also have to have a notion of causality, of action, events, and so forth. So you're quite right that I should have stressed that. The second part is, do you actually need to be embodied to have world models? I don't think so, or at least not as much as people think, but it's probably helpful. So I look to psychology to understand that. It's a guide. It might not be a perfect guide, but what I notice is that there are people in the world who are paralyzed, for example, and there are people with things like SMA who basically never moved around the world and still build pretty good models of the world in the sense that you can talk to them about it. They seem to understand things, even that they can't physically do, and so forth. So my view about embodiment is it's awfully helpful if you look at the developmental psychology literature. So once kids crawl around, they very quickly learn a lot of things about the world, but it may not be strictly necessary. And when we get to AI, like, it's kind of an open question. There was a critique by Emily Bender that I thought was too strong of LLMs that said that because they only have language, they can't really learn that much. They don't really have much understanding. I think the right view is if you only have language, you're limited, but you could probably actually do a lot. Or you can think about Helen Keller. She had a little bit of experience before she went blind and deaf at 18 months. She had a little bit of physical experience, and she's continued a haptic experience. But she, constructed very intricate models of the world and was able to write and be successful and influential and so forth. So I don't know how much and what kinds of experience are absolutely necessary. I do think that it's really great if you can get that experience. There's a field called developmental robotics, which I think has yielded nothing really important in 30 years of trying, but it might eventually. So what the problem is, in my view, so developmental robotics is like you let the robot roam around the world and it's supposed to learn something that it couldn't otherwise learn. And it stands to reason that you could do that. But what I often see are like experiments where somebody puts an apple back and forth in front of the robot and says, apple, apple, apple. And like, it doesn't get much further than that. I think that the problem is prejudice in the field of machine learning. So, the old thing about give a man a hammer and he thinks everything is a nail. So in machine learning, they tend to think that you need to learn everything. But I think if you look at biology, lots of stuff is innate. And in fact, the innate stuff is what allows you to learn. And I think the sophisticated people in animal psychology talk about innately guided learning, people like Peter Marler and Randy Gallistel and so forth. So what you can learn is a function of what's innate. What kind of structures do you have for world models? What do you have observational learning, imitation learning? Can you do more sophisticated things like that allow us to learn calculus or learn about cognitive science? So I think that the problem with developmental robotics is that they always start from a completely blank slate. And I think if there's one thing LLMs have taught us, it's that starting with a completely blank slate only gets you so far. Like LLMs, get all the sense data in the world in a certain sense. You get the entire internet, and they get lots of video data, and they still don't understand that objects persist in space and time. So you want to start with that, which is something that your company does some work with. You want to start with stuff like that. And then maybe the developmental robotics project might actually be really super interesting. It hasn't worked yet, but I wouldn't count it out for exactly that reason.
So Karl, what's your take on the requirement of action to build your world model?
I think if you just stand back and think about, can you be intelligent if you're not an agent? And if you're not an agent, or to be an agent, does that necessarily imply that some kind of action? So I mean, I agree entirely that physical embodiment is a really important aspect of being an agent, because you execute your agency through the body. But you all can imagine having agency without necessarily a sort of a physically instantiated body. But I think agency is the key thing here, and sort of begs the question, what is it to be an agent? Is a thermostat an agent? And I would argue that, from the point of view of artificial intelligence, agency is, to be an agent is to have intentions. And to have intentions is to have a world model of the consequences of your action, which necessarily implies a world model that is future pointing, that is counterfactual, that can deal with things that have not yet happened that you intend to happen, and gives you a sort of sense of selection. So I think agency is is a key thing that would draw a bright line between intelligence or artificial intelligence as represented by large language models and the kind of intelligence that we're talking about, one would aspire to, or we're talking about here. And just to, why would large language models not meet that mark? I think was implicit in one phrase that you were said earlier on in relation to large language models, implying that it's basically just a mapping between content and content. Another way of putting that, engineers have found some way to utilize universal function approximators to map from content to content. But there's nothing, if you like, in the middle. There's no understanding, very much in the spirit of sort of a statistician being comfortable with an autoregressive model as a description of sequences of data without understanding how those data were generated and how they might be generated under different interventions or different actions. So I'm coming back to defending my notion that large language models are rubbish, because that's another way in which they are rubbish, that they don't have agency. So when large language models now demonstrate, evince agency in the sense of being curious about their world, when they start asking questions, then I think large language models would be showing some kind of authentic intelligence, simply because they've now become agents. So I should say in defense, I was looking at John Tarney. Developmental neurorobotics, yes, there is a lot of rubbish there, but I think that there is also some wonderful stuff. I have to say some of the deepest questions which you actually spoke to, certainly from a sort of cognitive science and psychological perspective, some of the deepest questions about agency and how we acquire agency, beyond learning, and how that's contextualized by innate things. And I should also slip in here, inference is not learning, so inferring what's going on is, you can learn to infer, certainly, but inference is, I think, another level of sense making that we need. Most of the deepest questions to me actually come from either developmental psychology or developmental robotics. If you're so committed to an embodied context in the context of robotics. So just to sort of make sure that not all robotics has failed to deliver. I think there are some really interesting developments.
I mean, at the very least, I think the questions, and I should have made this clear, I think the questions in developmental robotics are really interesting. It's just most of the work that I have seen, I think, has a bias towards let's learn it all from scratch. It's probably not true of all of the work, and I'm sorry that I didn't see the talk earlier, which may have been very interesting. But in general, there's been this, I'm going to do things with a blank slate, which is the same thing we see with LLMs, right? They're completely blank slate, and people keep getting the same results. The questions that developmental robotics tries to answer, I think, are really, really interesting. And for that matter, you could say the same about LLMs. The questions they're trying to answer is, how do you get a mind from data? It's just that the real answer to that is you also have some stuff built in to have scaffolding around that data, so, in terms of the inference mechanisms, in terms of the learning mechanisms, in terms of some set of priors. And people tend to exclude those for whatever reason, but it's super interesting. And just to close the circle on agency, people do use LLMs as agents. They just don't work that well. There was a system a few years ago that nobody even remembers called AutoGPT. And there was a flurry on Twitter of people saying how it was amazing and how it was going to change the world. And after about a month, people realized it didn't work very well because of the reliability problem. So it would do things like you'd say, I want you to place this stock trade, such and such. And it would say, I'm on it. Because that's something that, content to content, you can approximate that people will say, I'm on it when you give them a request. But the system didn't have the passwords to actually place the trade. It didn't have the wherewithal to say, I don't have the passwords. And so, it would say that it had done this thing for you, but it hadn't. So it would feign agency. It couldn't really do agency because it didn't really have the world model, didn't really have the causal understanding, didn't really know what an action was. And so you can make it pretend to be an agent, but it's not a very good one.
But then again, like you could say, let's put the structure in there from the get-go, but also that we tried for an awful lot of time with expert systems before the rise of deep learning. Everybody was trying to do that.
So expert systems actually worked better than people remember them to. Their problem was they were brittle. And the problem with LLMs is they're brittle. So in the expert systems day, the really lousy thing about it was you had to pay a lot of like graduate students a bunch of money to fix all of the edge cases that they didn't do well. But they kind of worked. LLMs, they kind of work. But now you pay Kenyan contractors to fix all the errors, or you pay mathematicians or whatever, but they're still brittle. It's like very much a similar reality to before.
Yeah, but so instead of having two things that kind of work, what's then the road to have something that works?
Well, so, I mean, the question is how do we get something that works? So my view is if you look at classic symbolic AI and neural networks, that they are very complementary. And it is obvious that we should be spending all of our effort not gathering bigger databases, but figuring out how we can get the best of both worlds. So classic symbolic AI is great at representing world models. That's a lot of what the work was on. It is great at generalizing from small amounts of data in narrow contexts. Representing something as a function is an incredibly powerful thing. It allows you to generalize it beyond the cases that you've seen before, which is a weakness in the neural networks. But the problem is it's always had to be handcrafted. And of course, the really early stuff didn't represent probability and uncertainty very well at all. Then you have neural networks that are great at learning from massive amounts of data, but everything that they learn is too superficial and it doesn't generalize very well. You wind up with Teslas being summoned across an airplane parking lot and running into an airplane because the knowledge that they have is so superficial. So it seems obvious to me that we should want to bring them together. And it's just a political history. You have people like Jeff Hinton that are bitter because they didn't get funding. And so they dump on the symbolic stuff and tell people don't try to bridge this world. But the exciting reality is in the last few years, people have stopped listening to the Hintons and LeCuns of the world who said, don't do that symbolic stuff. It's bad. It's a waste of time. It's like putting gas engines when you already invented electric. I mean, Hinton really said this. And what's happened the last few years is people have worked on neurosymbolic AI and gotten good results. AlphaFold is a neurosymbolic system that does try to combine a generative system with classic search, for example.
So, Karl, what's your take on this? Is combining those two systems together, Frankenstein the system together, is that the way forward, or is something else or more needed?
That's your word, not mine, Frankenstein.
That's a good word. So, what did you imply by that? What did you imply by that?
Well, basically, it's as if you have system A that kind of works and has certain limitations. You have system B that kind of works with different limitations. So the obvious solution then is to bring them together. But I don't think it's so straightforward to just glue these vastly different things together and have the best of both worlds.
How to do it is not obvious.
Well, yeah, you might also end up with the brittleness of both.
Yeah, so maybe you know my answer. I can see from an engineering perspective you might want to try and do that, and of course the dangers that are entailed. But from the physicist's perspective, I think you'd be looking for what you want your intelligence to do and what principles should it comply with. Will it leverage or rest upon the technology that underlies generative AI as we currently know it? Possibly to a certain extent, but I think that would be an add-on. And of course, we've spent many months, years talking about amortization as one way of sort of using deep neural networks to finesse the problem of evaluating your beliefs about the causes of your content and what you are going to do next, mapping from content to belief structures, probability distributions, encoding that uncertainty. Just to bring in the sort of symbolic aspect, I am reading symbolic here basically as having a particular functional form for your world models or your generative models in which you have a discrete and relatively small number of states of the world that can be associated or equipped with a semantics or a symbolic aspect, so that you've now got a calculus or an aspect of these generative models that enable you to sort of make logical, inductive kinds of comments, if this, then that. And therefore, what one would be looking at from a first principles perspective is basically how would you use, technically, how would you invert a generative model that generated continuous consequences from discrete symbolized causes. And of course that then speaks to a particular class of generative models. And an interestingly sort of an interesting technical point here is the message passing or the inversion or the realization or the solution that would be required in terms of sense-making, decision-making, and action will be very different under a symbolic architecture. So you'll be using things like belief propagation or variational message passing. You would not be using the kind of continuous dynamics associated with transformer architectures or continuous state-space models. So I think there are implications about how usable sort of current deep RL-like technology would be if you're committing to a purely symbolic kind of architecture.
I love most of that, and I wind up being slightly more sympathetic to LLMs than you, but only slightly so. So I think, first of all, that I would like to strongly endorse the first principles thinking that you're talking about, and I agree with most of the principles that you laid out. I think that you need to have systems that do the kinds of things that you talked about, and I would agree that LLMs do not do those things. Probably the only difference is I think that LLMs can be subcomponents in systems that do those things. There are certain places where they're good at calculating kind of distributions in a very broad sense, and I think that they can help. I think that you want the sort of master of the system to be a symbolic system for a lot of the reasons that you just laid out. If you're going to do the inferences properly, then you really need to be able to look at the data, you need to be able to look at the priors, you need to be able to adjust them and so forth. And it just doesn't look like LLMs are good at that. What we have right now actually is a bit Frankenstein, which is in recent months, maybe the last couple of years, people discovered in the industry that scaling was not really working, scaling of pure pre-training. So most of the money was spent on the notion that if we just put in more data, we would kind of, well, the word was emergence, but I think you could call it magic. The notion was it would magically emerge that these systems would solve all the problems that critics like me have been pointing out for a long time. And what they realized last November, roughly speaking, so about a year ago, was that this was not working. And they had some intimation of that before. There's very interesting data from Grok 4 showing that what's really helping are tools. Well, what are the tools? The tools, they don't like to tell you this, but they're actually symbolic systems. The tools are things like Python, which is a code interpreter, which is as symbolic as you can get, right? It's full of functions operating over variables. Go back to Marcus 2001, who tries to defend what symbol manipulation even means. It's functions operating over variables. So what they have done is they have stuck those inside of LLMs, and that's actually most of what's helping now. But it is Frankenstein, if I understand the connotation of that word, in the sense that it's kind of like bolted on, which really fits the metaphor. It's kind of bolted on as an afterthought. And it sort of works. It works better than not doing that. Like, they actually get some mileage out of it. You look at this graph from Grok 4. I have a paper called How O3 and Grok 4 Accidentally Vindicated Neurosymbolic AI, which you can find on Substack. And it has this graph. And tools are doing most of, explaining most of the lift of the improvements that systems have recently gotten. So there is actually empirical leverage in Frankenstein, but it's Frankenstein in the sense that it's added on as an afterthought rather than doing what Karl is rightly recommending, which is to say, from first principles, what do we want cognition to even look like. We want to have agency. We want to have representations of uncertainty. I would say we want to have what I called free generalization, which I think fits in the world, in the sphere of things that Karl's saying. How are we going to do that? Well, we're obviously not going to do that with these opaque black boxes that don't allow us to make those kind of inferences in an informed way, representing uncertainty and so forth. So yes, you get something out of Frankenstein, and no, that's not what we really want here. What we really want is a principled way of bringing these things together, and that's where I think we should be putting our effort. And putting them together doesn't necessarily mean equal weight. It doesn't, you know, there's, I think, a whole universe of ways in which you can imagine, let's say broadly speaking, putting together things like neural networks that track distributions in some way with things like symbolic AI that can do a bunch of inferences and operations over variables and so forth.
Yeah, I mainly heard Karl was right, and that's how it always ends. We have a couple of minutes left. Maybe if there's an urgent question from the audience. Pablo, go for it.
Yeah, well, thanks so much for the discussion. I think it's very interesting. First of all, I have to say I don't use ChatGPT, I don't use Cloud, I don't use any generative AI for programming. I hire people for that. No, but I wanted to say one important thing. If
a man who cares about the quality of his results.
So, no, I wanted to say that if you go back to Moravec paradox and all these things that he said that will be impossible to solve, we are solving it. I mean, maybe not the right way that you want it, but language has been cracked somehow by statistical analysis. So, and this is kind of a result, right? So we are seeing that our machines talking, solving the Turing test. And this is very important. Even if you can criticize...
Solving the Turing test is not at all important. I'll let you finish your question, but I object
it was important
to that
in the 60s
premise.
at least, right?
Say again?
It was important in the 60s at least, right?
It was important in 1950. I just went to, I mean, if we're going to pause there, I just was part of the 75th anniversary of Turing Test Symposium at the Royal Society. Alan Kay spoke, I spoke. Some people dissected the test in great detail. The whole thing is available on YouTube. We spoke for 7 hours. Not one person in those 7, and Dermot Turing was the last speaker. He's Turing's nephew. Not one person defended the test in modern form. We all agreed that it was nice to open the discussion about what thinking is and could a machine do it, but we also all agreed that that test is really a test of human gullibility and how you could fool people, and we all agreed that we've known that since 1965 with the advent of ELIZA, which fooled a lot of people and contributed nothing to the understanding of intelligence, literally zero. The same thing with a system called Eugene Gustman that was arguably the first to win the Turing test. Nobody would ever look to Eugene Gustman's techniques for anything except how to fool people.
Yeah, but so just to conclude, if you can criticize it as you don't want that the way to solve AI as you want, so that we do to understand cognition, but it is right that it's working. So, and this is something that we have to take into account.
All right, I'm going to go after your second premise too.
Okay, so let me rephrase it. People are using it. People are using it hardcorely. So this is happening. So people are using it as another computational element in their lives. So it's a complement to our intelligence. So this is happening. So we cannot say that.
Is there a question in there?
Well, I'm just saying that we can criticize it.
That's not a question. So I'm going to respond now since it's not a question. Yes, I'm going to derive a question from your not question, which is, what do you make of the fact that people are using it, and how does that relate to the rest of the conversation? So yes, people are using it, sometimes successfully, sometimes no. There was an MIT study that showed 95% of companies using it are not getting return on investment. There was a study by Meter showing that productivity was actually cut in coders who were sure that it was going to help. So results are mixed, but some people are genuinely getting utility out of it. Not, however, universally. And there's a set of problems that works really well on and a set that it doesn't. Like people are sticking them into robots, but nobody knows how to make a robotic plumber. Like, there are lots of things that we have no idea right now how to use these things for. These things are not that great at science unless a lot of scientists spend a lot of time carefully constraining them to do a particular problem. If you just throw into a chatbot and say, solve cancer for me, you're not going to get throw into an LLM, you're not going to get anything out of it. that is useful. So there are things that are useful for, and there are things that are not. One of my favorite quotes in cognitive science is from Chaz Firestone and Brian Scholl, two cognitive psychologists, and I can almost do it from memory. They say cognition is not one thing but many. And they go on to give a bunch of different examples. I don't remember all of the examples. But the point is that there are many different facets of intelligence. In fact, I'm co-author on a paper with Yasho Bengio and 30 other people. Dan Hendricks is the lead author. That came out yesterday. I think the website is agidefinition.ai. And the point of the paper, which is not entirely successful, I criticized my own paper in my own Substack yesterday, is not entirely successful, but what it tries to do is to fractionate cognition into a bunch of different things. And there's a nice little graph in there with 10 aspects of cognition that they look at based on a classic framing of cognition from Cattell. You could find lots of others. That's part of my critique. But on that, you could say very reasonably LLMs are good at 3 or 4 of these and not so good at 7 of them or something like that, 6 or 7 of them. So they are useful because they do certain parts of cognition well. They are much less useful than you could imagine AI to be because there are many aspects of cognition that they don't do well. So, thermostats, which are the world's most primitive agents, as we just learned, and you can actually make that argument. Thermostats are useful, right? And they do an intelligent thing, which is they determine the temperature and they control the temperature in a room. They are a bit of intelligence by some definition. You could argue they have a semantics and argue that LLMs don't have a semantics if you really wanted to have some fun. But they're limited. They do some things and not others. We should take another question.
We're actually at time, but let's take an actual question.
Hi. So my question is about agency. Sorry. So I think the lack of agency also creates some of the problems in the LLM we see today. Like GPT-5 made a lot of mistakes, but you cannot threaten and say, if you keep making mistakes, I'm going to replace you with GPT-6 because...
Well, you can tell it that. It won't make any difference.
Exactly, because it doesn't have agency. You cannot take agency away from it.
Yeah, I'll let Karl answer too, but my view is that that's not the core problem for why LLMs don't reason well. The core problem is they don't have world models, they don't have a proper semantics, they don't have abstract representations. It's not a motivational question. I mean, they kind of do what you're telling them, or they try to do it. They don't really understand any of it. They're all just doing pattern matching over language. Something that I find hilarious, and then I'll turn over the mic, is that the world that we have wound up in is one where everybody in machine learning, I'm exaggerating, many people in machine learning have a violent aversion to putting any innate structure in their models, versus AI, to its credit, does not. But most of them do. But then they put all this innate stuff in their system prompts. That's actually innate. The system didn't learn what's in the system prompt. Some engineer tried a bunch of stuff out and did a bunch of experiments and said, let's build that in. That's more like evolution than learning. They're building that thing in after saying that they hate innateness, after dumping on me for saying we need innateness. They stick it in the system prompt. But what's even more embarrassing, or maybe equally embarrassing, is that you say stuff like, don't hallucinate in your system prompt. Like Apple literally had that. Does anybody remember the Apple BBC News summary debacle? Like it literally said, don't hallucinate, and it hallucinated anyway. So like you're talking to a wall and telling the wall don't hallucinate doesn't really work.
He's very good entertainment value. Thank you, sir.
I try.
So just briefly responding to this, I think one has to acknowledge that sort of from an engineering perspective, large language models are beautiful. I mean, they are a really impressive bit of engineering. But it's interesting to reflect, why are they so beautiful? Why do we find them so alluring? Because it's not the RL part of it that makes them so compelling. Because the objective function is just prediction. It's just predicting the statistics, very much like a sort of autoencoder, but in time. So I think that's interesting to note. It's not reinforcement learning that's sort of realized the beauty that we witness with large language models. It's the use of universal function approximators to do prediction, basically. But what? And I think that's the key thing. It's just predicting stuff that we do. So I think it's the fact that generative AI just generates the kind of stuff that we generate that renders them beautiful and interesting. But beyond that, there is no utility.
In other words, Karl has told you today, and I'm not fully endorsing, LLMs are rubbish and they are parasites.
We have one final question, and then we can head off.
Well, it's a two-parter. The first parter is curious whether you would have agreement on the kinds of systems that, like Tim, you've been working on, could be and have been developing, could be considered to be a kind of neurosymbolic AI. And the other is, so the question of do language models have a world model or not? So I'm currently organizing a special issue of Royal Society. Gary's contributed a really excellent article on the topic of world models. But the question is like, is it something of a suitcase word we need to unpack? And maybe there's multiple kinds of world models that are different, that are differently meaningful. And I guess rather than is there one kind of world model or not, how would people feel about there being like a typology of world models? And do you think it could be possible to come to agreement on this? Or is that fool's errand?
Taking the last part first, no. It's unlikely that we will come to agreement. I think a typology is actually a good thing and a worthwhile project. I just wrote a piece for my Substack about, I forget the title, but basically how the complete lack of world models was undermining LLMs. And the example that I gave, and I'll come to your point about multiple definitions, was that you can't take an LLM and have it reliably play a game of chess. And there's a really interesting pattern of behavior, which is an LLM can repeat the rules of chess. It can even answer questions like, can a queen jump over a knight? But then it will actually have a queen jump over a knight illegally when it plays. And so my argument there, and I will admit that there are different ways you could construct the term, but my argument there is it has not made a model of chess. This is despite being trained on millions of games that are there on the internet, being trained on the rules which are in Wikipedia and chess.com, being trained on books like Bobby Fischer Teaches Chess, which is where I learned how to play a decent game of chess, and so forth. That's all there, and it doesn't actually absorb it. So for me, I would want to say if you can't do that, you don't really have a world model even of chess. And in fact, LLMs have been beaten by an Atari 2600 from 1975 with its cartridge from 1975 in chess. And so the Atari 2600 does have a world model of chess in the sense that I'm defining. I'm open to the fact that other people talk about it in different ways, and we talked about that a moment ago. There's this function prediction sense, and I think that carefully articulating all of that might have some value. Like there's the sense that I'm describing where you have an interrogable system. You can ask it questions like, can queens jump over knights? You can expect that it will behave in a coherent and consistent way with those things that it repeats. So do LLMs have coherent world models as I'm describing it? Clearly not. But are they predictive functions? Well, you could make that argument. I mean, what does it mean if you get the predictions wrong? But you could get into that. I think it would be a service to the field to try to spell that out more carefully. Do you want to add anything?
Maybe a closing word, Karl?
Well, actually, I don't think I need to. I think I agree entirely. But I
He
think
agrees with me.
Yeah, absolutely. Oh, I always do covertly, but never want to be so too explicit about it, because I'll get into trouble. But I do think if the question was, do we have a need for an ontology of world models? I certainly think that would be really useful, and just make the obvious point that, of course, each artifact and each person, any instance of intelligence will have its own world model fit for purpose for the world and the niche and the content with which it has to exchange. But there seems to be a sort of deeper thing here, which is a distinction between the implicit world model in a current generative AI, which is, I repeat, much more sort of so in the universal function approximation sort of analogy, I was implying a mapping from content to content or consequence to consequence. And to me, that is a very different kind of model, typology, speaking, from a mapping from cause to content, consequence. So I think these are fundamentally different approaches to dynamics, intelligence, agency, however you want to frame it. So I think it would be useful to have that fundamental distinction in play. I see this distinction in many other fields, and it may be useful just to sort of reinforce that. So you've got a commitment to either this kind of descriptive model, this consequence to consequence or content to content mapping, or you've got a commitment to the true kind of understanding world models that are implicit in a symbolic setting.
And I will end on a note of agreement and with a reference to somebody else, because I think we have to wrap up. I agree with everything that Karl just said, and we didn't mention Yuda Pearl's stuff on causality, his ladder of causality, but it's very consistent with this, the 3 rungs of causality. It's not framed in quite the same language, but really world models are core to what he's saying as well, and it's exactly consistent with what Karl is saying. You don't want to just learn correlations between content. You want to have a world model that intervenes, that you're doing causal analysis over. So Karl agrees with me, I agree with Karl, and we thank you very much.
Thank you.
Fantastic, as always.